Hello everyone, our lesson today about the polynomial function. How can represent the polynomial function? If you have f is a function from x to y and f maps x to y. For example, if x equal set of 2, 4, 6 and 8 and y is a set of 1, 2, 3, 4, 5 and 6 and the function f from x to y where f of x equal half x, then we want to write the set of the function f and represented it by an arrow diagram, then find its range. So we want to have substitution of the domain, the set of x, in f of x, that f of x it will be y, the codomain of this function. So our f of x equal half x. So by substituting every domain that we have in the set of x, f of 2 it will be half times 2, it will be 1, and our order pair it will be 2, 1. 2 belong to x and 1 belong to the codomain. Then substituting 4 equal half times 4 it will be 2 and our order pair it will be 4, 2. Then f of 6 by substituting x with 6, so half times 6 it will be 3, so our order pair it will be 6 and 3 as follow. So we find that f of 8 it will be half times 8 it will be 4 and our order pair it will be 8, 4. So the set of the function f it will be that order pair that we calculated: 2, 1, 4, 2, 6, 3, 8, 4. So our range it will be is the subset in codomain 1, 2, 3 and 4. So we want to represent these sets in arrow diagram. So we draw set of x and set of y, then draw our order pair by an arrow: 2, 1, then 4, 2, 6, 3 and 8, 4, and this is an arrow diagram. Polynomial function. If we have k of x, the function it will be 5. This function it will be constant function. If we substitute any real numbers in of domain of x, the codomain it will be 5. So our order pair it will be any number in the real number set of real number it will be 5. So this is the polynomial function. Another example, f of x equals 3x plus 4. By substituting any real numbers in this function, so we find that we have a value of codomain. So also it will be polynomial function. Then g of x equal x to the power 2 minus 5x plus 6, as we find that in every set of x of the real number it will be have the codomain of g of x, then it will be polynomial function. And the last one is also polynomial function. By substituting any real numbers, so we will find that we have a value of codomain. Another not polynomial function, like this example, f of x equal root x. So we want to have any any codomain in the real number, substituting in x, it will be have the codomain. We find that the root of x not polynomial because every negative real number don't have a number under the root. So any numbers like this, root -1, is not polynomial function. K of x equal 1 over x. So by substituting any real numbers, we find that it not belong to a polynomial function, because if we substitute with 1 over 0, it will be, the answer is undefined. The last one, f of x equal x times bracket x plus 1 over x. We find that also that 1 over x is not a polynomial function, because if we substitute by 0, so the denominator it will be 0, also it will be undefined value. In polynomial function, we don't simplify any of this function. We don't simplify any of this function. So it is called not polynomial function. The degree of the polynomial function. What is the degree? The degree is the highest power in any expression. So k of x equal 5. This is a constant function, that is the 0 degree of the polynomial function. F of x equals 3x plus 4. The highest power here, it will be 1. So the degree is first degree of polynomial function. G of x equal x to the power 2 minus 5x plus 6. So we find that the highest degree it will be 2, then it will be the second degree of polynomial function. Last one equal 1 plus root 2x minus 9x to the power 3. So our degree it will be 3, so it is the highest power, then it will be the third degree of polynomial function, and so on, with the increase of this degree, maybe fourth, fifth, sixth, and so on. Our example, which of the following is defined by the following rule represent a polynomial function, then determine its degree if it is a polynomial. So f of x equal x times root times the bracket x to the power 2 minus 3. So without simplifying, this is a polynomial function, because every domain that we have in the real number have a value in the codomain. So it is polynomial function, and we want to find our degree. So by simplifying this, x times x to the power 2, it will be x to the power 3. Then multiplying x multiply -3, it will be -3x, like this. So the polynomial function of third degree. Another example, f of x equal x times 2 over x plus 5. So as we know that any rational that we have x in the denominator, it will be substituting by the real number like 0, it will be 2 over 0, it will be undefined. So this function is not polynomial function. F of x equal x to the power 2 minus root x plus 1. We find that this is not polynomial function, because root of x it will be substituting by any negative real numbers. So the last example, it will be f of x equal x to the power 2 minus x power 2 minus 4. So this is polynomial function. By simplifying this function, we find that x power 2 minus, it will be multiply x to the power 2 minus x power 2, and negative times negative, it will be positive, so positive 4. By simplifying, we find that x power 2 minus x to the power 2, it will be simplify, it will be 0, plus 4, it will be constant. So the constant value of this function, it will be 0 degree. Another example, if f of x equal 2x plus 5 and g of x equal x minus 6. Find f of 1, f of 2, g of 0, g of 2, and g of 3. Then prove that f of 2 plus 3, g of 3 equals 0. By substituting every function that we have in x in our function f of x and g of x. So f of x, it will be 1 by substituting x with 1. So 2 times 1 plus 5, it will be 7. The function f of 2 equal, substituting 2 in x, 2 times 2, it will be 4, plus 5, it will be 9. G of 0, our function g of x, substituting here with 0. 0 minus 6, it will be negative 6. So g of 2, by substituting also x with 2, 2 minus 6, it will be negative 4. And g of 3, it will be also substituting by 3, then 3 minus 6, it will be negative 3. Then we want to make the proof that of f of 2 plus 3 g of 3 equals 0. So our left hand side, it will be 9, because f of 2, it will be equal 9. Then plus 3, we have the constant value here. Then g of 3, it will be negative 3. So we have f of 2 and g of 3 here equal 0, equal the right hand side. This is example, if function f of x equal x to the power 2 minus 2x plus 5, then we want to find our function f of 1, f of 2, f of 0, f of negative 2, f of half, f of root L5. Then prove that our function, it will be equal. So by substituting f of 1, by substituting x with 1, so 1 power 2 minus 2 times 1 plus L5, it will be 4. Then f of 0, it will be 0 power 2 minus 2 times 0. So this value will be neglected. So plus 5, it will be 5. Then f of negative 2, our function between two brackets, negative 2 all to the power 2 minus 2 multiply negative 2 plus 5, it will be 13. F of half, by substituting every x with half, so our answer, it will be 17 over 4. Then the last one, it will be f of root L5 equal root L5 power 2 minus 2 root L5 plus 5 equal 10 minus 2 root L5. So then we want to have our proof that for these two functions. So the left hand side, substituting in f of x, then f of 2 root 2 plus 1, substituting in every x, we have, by simplifying this into the first square plus the second square plus all multiply. So we have 2 root 2 all to the power 2, it will be 8. 1 power 2, it will be 1. So plus here, it will be positive. 2 times 1 times 2 root 2, it will be 4 root 2. Then by multiplying every one here to the bracket, so negative 2 times 2 root 2, it will be negative root 2. Negative 2 times 1, it will be negative 2 plus 4. So 4 root 2 neglected with negative 4 root 2. So the answer, it will be 8 plus 1, it will be 9, minus 2, it will be 7, 7 plus 5, it will be 12. The right hand side, it will be substituting every element with 1 minus root 2. By simplifying this as follows, we find that we have additive inverse here, it will be neglected with 0. So by calculating this value, it will be also 12. So the left hand side, it will be equal to